Morning, everyone. There are many dramatic moments in the history of science, and one of those happened on this date in 1633, June 22, when the Holy Office of the Roman Catholic Church forced Galileo to recant his view that the Earth went around the sun. The common sense view of the universe is that the Earth is at the center. This was believed by Aristotle and the ancient Greeks and by most people. You don't feel any motion, right? And the sun sure looks like it moves across the heavens. But already in the first century, Ptolemy, an Egyptian astronomer, theorized that it wasn't quite that simple. And he explained some of the motions of some of the heavenly bodies with the idea that they had their own little epicycle. But the Earth is still at the center. Nicholas Copernicus was a Polish priest, and he had a theory that if you put the sun at the center of the universe, then the motions of the heavenly bodies become much more predictable, much more elegant even. But it was just a theory. Tycho Brahe was a Danish astronomer, and he started observing the heavenly bodies. He did this for years, every day, and he took pages and pages of notes. And he had a cool little observatory off the coast of Denmark. Here it is. And he went down into the bowels of this thing for months and months and months. And his assistant, Johannes Kepler, took all the notes that Brahe had assembled and tried to see if there was some mathematical formulae or consistency. And he came up with the 3 laws of planetary motion. And the key thing here is people are using math to explain the motions of the heavens. And Galileo was a math guy. So here's Galileo's birthplace in Pisa. He lived in Padua, outside of Venice for a bit, but eventually moved down to Florence, where he knew the Medicis and so on. And while studying, he was very interested in what we know as acceleration, why things tend to go faster as you drop them, or balls move in arcs. They don't just go straight and then drop. But for our story, it was the telescope. When he got his hands on one of these, they were invented in the Netherlands, he was fascinated by the telescope, started building his own. He learned how to grind lenses. And one day, he set up the telescope in his backyard and looked up at the heavens and started to describe what he saw. So he took notes over months and months and came out with this little book in 1610, The Starry Messenger. And this took Europe by storm, partly because it said that the moon had craters, kind of like the Earth. It wasn't pure and pristine like it looked. So the Pope during our story is Urban VIII. Before he was the Pope, he was Galileo's friend. They had talked. They knew each other. The Pope was sort of interested in science. But when Galileo came out with this book, Dialogue Concerning the Two Chief World Systems, and made the church and the anti-Copernicus people look foolish, Urban took this personally. And he and Galileo never spoke again, even though Galileo meant the book to be more of a rhetorical device. So one thing led to another. He got in trouble. He got called before the church to recant. The big issue for the church was that the new view seemed to challenge the Bible, because there are verses in the Bible that talk about the sun moving. Galileo challenged that. He did recant, sort of, was under house arrest in Arcetri, south of Florence. You can see the little map dot here. And you can visit that house today. And this was the house he was in when he died. And it was while here he went through his last 40 years of notes and came out with this book, Mathematical Discourses of the Two New Sciences. This is considered a foundational work in the history of physics, influenced Newton, and even Einstein said that this was a work of genius. And many people think this is his greatest work. So he died in Arcetri. Eventually, he was buried in the Church of the Holy Cross, Basilica di Santa Croce in Florence. Maybe some of you have been there. And as we look at our universe today, we all agree Galileo, one of the main players in our understanding of the forces at work behind it.